Uh, we mentioned that the main difference between the milling tool and the turning tool is that in the turning tool, the part is rotate. The cutting tool is single head, just one tip, moving to do the cut in one direction, and the spinner is going to be on the other direction. So we have two axes. One of them is going to be linear, the other one is going to be rotational. In the milling machine, we use mainly three axes linear, X, Y, Z. The part is fixed. The cutting tool is rotating. And it's moving around. The fourth axis is going to be a rotational axis around the Z axis. Okay, now that's the main differences, but you can still see that the programming of the G code for the turning is going to be much harder than the one you are going to have for the milling. For this assignment, you will see that we are going to have very simple coding. More complicated shapes, like the one I'm going to give you for the CAD/CAM assignment, you will see that maybe we are going to have around 150 lines. Still, 150 lines don't consider to be at all good. Just imagine if you are going to do the machining for a block, and you are going to make an engine block. Usually they don't make engine block by the milling, but this is just an example. Why we don't make engine block with the milling? Why we usually cast it? Yeah, because we are going to waste material. And wasting material is one of the problems we have in manufacturing. So we take it by casting to the net shape, and then we are going to do the final shape by simple machining. So the problem is that you can see that the project doesn't work. So I would like you to come and follow the screen here. I passed you this slide yesterday. I shared it with you. I sent you an announcement for that. But anyway, it's going to be good to follow up with that because we're going to have some examples which are going to lead you on how to write a G code. And by the end of the tutorial, some of the students will come to the whiteboard and try to do this example. So we said that this is what we are going to have in the profiling. I should just jump this way. Yeah. We're recording, so I would like you to make space. Jump this way. Okay, so we're going to learn how to do the N and G. Well, G and M, which is the geometrical movement, and the M is the miscellaneous movement. And write the code for that for the machine to follow the path of the cutting you are going to decide until we are going to have the final cut. We talked about these things yesterday in the lecture. So if I'm going to start reading the code, does anyone remember what this code means? What the M03 means. I gave you an example for that yesterday. That means that the motor is going to start. The next, when I'm going to say GO, that means I'm going to have movement without doing any cutting. The X, Y, and Z is going to be the coordination where we're going to take the center point of the cutting tool, which is usually is going to be a circular shape in the milling machine, to this point. The tip, the center tip will go to this point. And then, when I say G, Z minus 1, that means that the cutting tool is going to go down to the level minus 1 inches beneath the surface of the workpiece. So now these are very complicated things for you, something like an alien's language, but by the end of this sheet it's going to be very simple. So creating an NC program, we need the manual code writing, which we are going to apply today. We can do the computer-assisted programming, we're choosing the APT language. It's not the CAD/CAM. This one is only a CAD/CAM. You describe the geometry to the machine. You give it points, and then you are going to describe what the movement, the tool pattern is going to be between these points. I'm going to use this point as a center point of a circle, or I'm going to use it to make lines or make arcs. And we have the CAD/CAM generated program. This one is much easier method and the most common method in the technology we have nowadays. You just have to be familiar with one of the CAD softwares. Make the geometry is going to be very accurate, and then you take it to an app. You're going to do the tool pathing. You be sure that the final cut is going to be the final measurement you would like to have, and then generate what we call the G code and send it to the machine. Next week we're going to introduce this one. We're going to have a presentation on this one, and you are going to have an assignment for it. It's going to be the same shape you have in the part one of this sheet, plus another complicated, well, it's not going to be complicated shape. Another shape you have to do the tool path for. It's going to have things. This one doesn't have something. I downloaded the SolidWorks on these computers, so for the Mac people can do the SolidWorks, the geometry here, and download any CAD software on your Mac, and then you can download the app and do the milling in your computer. Okay. So for the manual which we are going to do today, the NC program, we are going to use simple codes like the G and M codes, or what we call as well as the machine codes. So we run the part program to create components for the machine. We are going to have lines of code. We are going to have a line of code dealing with the numbers N, followed by the G code. And then we are going to have the coordinations where we are going to take the machine to. We can use the F code for the feed rate and the S code for the spindle RPM value. Standard G and M codes we are going to use are the G90, which tell you that we are going to use the absolute coordinates. Do you remember what the absolute coordinates, right? We're going to have an example for that anyway. G91, if I'm going to use the incremental coordinates. If I'm going to use the code G00, that means I'm going to have rapid move from one point to another without doing any cutting. The G01, that means I'm going to have straight line cutting with a certain feed rate. The G02 and G03 are going to be the circular arc. For the G02 is going to be clockwise. G03 is going to be counterclockwise. The M03, that means we're going to start the spindle to rotate. The cutting tool will start to rotate clockwise, counterclockwise direction. If I'm going to change it to clockwise, I'm going to have M04. For the M00, that means I'm going to end the program, stop the spindle, and go back to the beginning of the program for repeating of the process. If I'm going to use M05, that means I'm going to stop the program and take off the part. So we have to make all these codes to create a program line like this one. So first we're going to have the N15. The N15 actually is not going to be read by the machine, but it's for your reference. Either you're going to do the work, writing down the program by hand, or you're going to do it with the CAD-CAM. You need the reference of the line so you can find the error and change it by looking for the N15, the N number in front of it. Usually we start with the N0, then we jump directly to the N10, N20, and N30, and so on. Why we make it by 10? If we would like to add something in the middle, so we are going to have 9 steps, 9 lines can be inserted within. And this will be the best way. G90, that means I told the machine to follow the absolute coordinations. That means the point I'm going to go to next, which is have the x value of 100 and y value is 50, and z is -1, is going to be reference from the origin point, the 0, 0, 0 point. The G00, that means it's going to go to there with a rabbit feed. I'm not going to have any cut. So I put here the feed rate just to tell the velocity of the machine to move to this point. Another example of the line is going to be N30, G03, x minus 20, y is going to be 30, and I10, J2. Now for the I and J, these are new symbols. These are the old symbols used to be used in the programming of the G and M code to create circles and arcs. Now they are not in use anymore, just in old machines, because the new machines have the R code. You just set next point from the origin point and what will be the radius value. Now, what you can tell from this line? G03, we're making counterclockwise line. That's all it is. We have X and Y value, and I and J value. What you can find here? What did strange thing? The X value is negative. That means we're not using the absolute coordinations. We're using the negative value. That's when we're using the instrument position. We go back to the other direction of X, to the left. That means before this line, we had line which set the G to 91 before we doing that. Now, just to remind you before we go further, if I'm going to write the first line, and I'm going to set the next line without changing the G90, that means it's going to make the G90. It's going to be absolute. If I'm going to change the G00 to G01, that means I change it from the rapid movement into linear interpolation during cut. If I didn't change the feed rate value, that means it's going to use the same feed rate, unless I'm going to do this cut. For the X, Y, and Z, if I'm only going to change one of them, the other two is going to remain the same values. Now, for the next line, if I'm going to change the value of the Y, the Z and the X are remain the same. That means we're only going to move in the Y direction. The other two X's are going to remain the same. What the other thing I have to tell you about? The most important thing is to set the program 0 or the datum point. Usually, before I get to go to the next thing, usually if you try to do a cut for any piece, this will be the original part. You have to set your datum point, which have the 0, 0, 0, on the top surface at the bottom left corner. That's my work, that's the profiling I'm going to have. So I set my datum point at this point. The Z is going to be the top surface, and the Y is going to be in this direction as usual, to the top. The X is going to be to the right. Okay? So actually that's what I'm going to say in these points. So it's point on the job, and sometimes on the stop, but usually on the top. Chosen by the party programmer, and to which all the coordinates are different. Referred origin of the system value of the 0, 0, 0. Now, how to set this one? You can have the example of this laser cutter. This laser cutter is sort of a CAD/CAM device. It can be a milling machine, can be described as a milling machine, but the cutting tool in this case is going to be a laser instead of a cutting tool. Of course, in this case, you're not going to have any offset. Where the laser is moving, that's where the cut you are going to have. In the profiling case, in the milling machine, where the circumference of the cutting tool is touching, this will be your cutting path. But your tool path is going to be offsetted by the radius of your cutting tool. Usually, if you would like to set the machine to the datum point, you have to drive it manually. Then you set, this will be my 0, 0. Then it's going to take all the reference you are going to set to the program regarding to this point. So we said that usually is going to be at the top surface to the bottom left-hand corner of the finished job. That's the most common one. That's an example for it. You can choose at different places, but usually the yellow point here is the program 0 datum. So if you take a look to this photo on the side, the blue line is the stock material. The black one is the finished part. Everything within has been moved by the milling operation. we said that the coordinate system we have on the milling machining is usually the Z direction is going to be the vertical one, where the cutting tool is going to rotate. Some of the machine, the cutting tool is rotating horizontally, so you have to change the Z value. The longest side of the table is the X direction, and then the other side is going to be the Y direction. I said that if the cutting tool is rotating horizontally, this will be your Z direction.
So Y will be the Z direction.
Exactly. The Y is going to be the vertical. Okay, so the x-axis is along the spindle axis. The x-axis. The x-axis is along the largest side of the direction of the table, and the y-axis is defined by the right-hand screw direction. In the absolute dimensioning, we are going to set all the values for the points with regards to the reference point 0, 0 point in the x and y. Of course, what is that? We're always going to reference it to the surface of the work part, either negative below it or positive above it. For this case, in the absolute, we have point 1 to 4. You can see that the coordination of these points are going to be with reference to the 0 point. So, for example, point number 1 is going to have 1 inch in the x-axis and 1.25 inches in the y-axis. Point number 4 is going to be 1 in the x-axis and 5.87 inches in the y-axis. That's the absolute dimensioning because all the points are referenced to the 0, 0 point. How are we going to set the absolute values? G90. If you are going to just write down the program, you forgot to put the G90, it's default in the machine. Unless if I'm going to make it G91. The incremental positioning, now in this case, point number 1 is remained because it's from the reference. Now I would like to take it to point number 3. The x values remain the same. Point number 3 is not going to be read as the addition of the x values between the points. It's going to be just a distance from point number 1 to point number 3. Okay?
Because it's not.
Yeah, so you are going to reference the point from this point data. So I'm not going to change the x value. I'm going to add this y value. So you just tell the machine how long it's going to move along the y-axis.
That's because it's G91 and not G90.
Yes. As well as this machine, the incremental one, is the one which using what we called yesterday the open loop. Doesn't have a feedback. So it doesn't do the thing from the reference, but it's number of the pulses we are going to add to move a certain movement. The other one is the polar coordinates. That's very rare to be used, but once again, if you would like to do what we call the indexing today, then you are going to reference all the points from the center on a circle, then on a certain angle. The control statement we are going to have once again don't involve any movements. We are going to use, for example, the N value for setting the spindle on. We are going to choose the F200 to set that the feed rate is going to be 200 millimeters per minute. T05 to pause or double for a given time. For example, if you'd like to change the cutting tool, usually using the M06. And G25 is going to be the subroutine codes, because sometimes you do some work using cutting tool number 1, then you have to call a subroutine to do the other job using another cutting tool. And then you go back to the original program to finish the work using the previous point and so on. So we have a program, the main one, and subroutine calls from time to time. If you're using the MATLAB or you know how the MATLAB works, certain equation need to have a subroutine to do sub-equations to feed back this equation to control. The same system we have on the GNN program. For the geometry statement, we call it the G code. We said we have G00, G01, G02, and G03. G03 are the main one you are going to use in the manual programming. We said that the G00 is going to be just rapid movement, G01 is going to be a linear portion, and G02, G03 is going to be clockwise and counterclockwise interpolation. We have some machine miscellaneous statement we call once again the M codes, like M08 and M09, which is the turn on and turn off the coolant fluid. We have the M03, which is going to turn on the spindle in counterclockwise. And we have the program to set and go back to the beginning is going to be M00. Usually you have to put the M03 at the beginning, otherwise the spindle is not going to work. And you have to put back the M00 at the end, otherwise the spindle will continue working and you will not be able to take off your part. For the linear interpolation, this is an example to take it from one point to another. We have to start the program, start the motor M03. We are going to have line number 1, G90. We are going to use the absolute values. And we are going to take the cutting tool rapidly to the point where X is equal to 30 and Y is equal to 15 and Z is equal to 5. Now, what does that mean? Well, we are going to take the cutting tool in this case.
To absolute coordinates from 0, 0.
Yeah. To where the point is going to be X equal to 30. That means that the lower bottom, this point, at the lower, this one. Okay? The Z is 5. What does that mean?
Height of the surface.
That means the cutting tool, yes, is tip is 5 millimeter above the surface of the work part. The next step, you can see that I just changed the G value to G01 instead of G00. That means I'm going to have an interpolation. I'm going to have a work. I change the Z value to -5. That means my cutting tool is going to be penetrated beneath the surface of the work part by -5 millimeters in the negative direction of the Z. This is my surface. I'm going to go -5 millimeters beneath it. The feed rate is going to be 100 millimeters per minute. So actually this will be a drilling operation. The line number 3 is going to be, the X is going to be 80. The Y is going to be 60. The feed rate is going to be 120. I didn't change the G value, so it's going to be an interpolation. This will be cutting. I changed the X value and the Y value. The Z will remain the same. And the feed rate will be faster because I'm going to do a linear interpolation. Then I'm going to add the cutting tool to go rapidly to the point where the Z is equal to 50 millimeter above the surface. Then turn off the machine. Well, actually, that's not an accurate example because the cutting tool will be at the top of the part. We should take it away before we can remove the part. But at least the spindle is turned off. For the circular interpolation, to do a circle cutting an arc, we have to use the G02 or G03 depending on your application. In this example, we are going to do the cutting from the top point to the lower point and make an arc with a radius of 25. So my example is going to be start the program, take the cutting tool rapidly to the top point, where we are going to have the X value is equal to 40, Y is equal to 60, and Z is going to be 5. Then I have to do the drilling to the depth of -10 millimeters. So just take the G1, linear interpolation, to the Z is equal to -10 with a feed rate of 100. Then the G2 is going to make the circle arc with the radius of 25. Now you can see that this radius is not for the outer wall, not for the inner wall, it's the tool path radius. That's mean, yeah. According to the hash line, the center point of the cutting tool is going to move. That's what we call the tool pathing. It's not the cutting path. They are different between both. Now the distance above the hash line to the outer wall and the distance below that to the inner wall is the same, which is equal to my cutting tool is circular. It's going to be set here. This distance below the line and this above the line, the offsetting above and below is equal to what?
The size of the cutting tool.
The radius of the cutting tool. Unless, if I'm going to have a smaller cutting tool, then I have to do the cut twice.
Okay.
Okay? That means I have to do the upper one, then the lower one, and two pathing. And that's what I'm going to have in one of the examples. Okay, then who will explain to me what we're going to have in the line number 3? Translate that to me.
So it's moving to those coordinates x15 and
Y.
by that absolute coordinates
Yeah?
and radius of y.
So we're going to which point?
Going to the ending point.
Ending point. And what will be the direction of my movement for the circle and circulation? Because we're using G02.
Yes.
G02 is going to be in? No. G03 is counterclockwise. Clockwise. So we move from this point to this point. Clockwise, the radius is 25. The old system, which is the I and the J, is tell you that the I is 40, the J is 35. How can you explain that to me? The I is 40, that means my center of rotation is going to be where the X is equal to 40. And my center point have the coordination in the Y direction, which is 35. So we give it 2 points, and we give it a center point, and we would like to take it in this movement with reference to the center point. So it will calculate that the center, that the radius is 25. That's the old method. When we, as I told you, when we used to do the program assistant writing, we used to give a center point. And then to understand that this will be my movement, I should stay away from this point, and this will be my center point. The clockwise movement, then the generated verse again be 45. Yeah, nobody using this one anymore.
So if we use the radius R, we don't have to use the
Yeah. That's just an example. One of the examples. This is another example. I will say that the I is going to be 0 and the J is going to be minus 25. In this case, this will be my radius.
Yeah.
But this was the most common one, and now we don't have to use these two. Because most of the machine, the MCU unit, the machine control unit, is reading the R code. Then after I finish this cut, I will take the cutting tool to the level of 50 millimeters, then go back to the origin point and turn on the spindle item to the point of.
If you put like angle program, you make the machine go back to the original position.
Yes. Yeah, you have to do that. In the example you have in your hand, in the part number 2, you can see that I put it a point, which called the home point. That's when you have to start the work from there and finish there. So we talked about the absolute and the incremental, so I don't need to repeat that. Now, if we're going to have this example for the tool pathing, if I would like to take this cutting tool to cut the purple line, and this will be my cutting path. This is my cutting path, this is the purple line. That's what I'm going to have at the end. The black line is the tool pathing. It's offset by the radius of my cutting tool. You have to remember that. Now we have something wrong here. This is not the start. This is start point, but this is not the datum point. The datum point is this point, the tool line meeting, the purple tool line meeting. Well, this one is the starting point of my work. If I'm going to use the incremental programming. Incremental, that means I'm going to move it from this point to that point. I will get this distance. How long I'm going to move in the X direction from this point to that point. So that 250 in the incremental. And I have to go with the height of 35. It's the incremental between this point and that point is going to be not from the reference, it's going to be just the distance between them in the y direction. No change in the x direction. That's the incremental, not the absolute.
Oh, yeah, so
Then I have to move from this point to that point with a radius of 40. That's radius is called the tool pattern. If my cutting tool is 10 millimeters, what will be the radius generated by the cut? I'm cutting 40 millimeters radius above the line. The cutting tool is 10 millimeter diameter. So what will be the actual arc I'm going to have from the cutting? 35. I subtract the radius. If this position is 35 from the y direction, that means it's going to be 40 after the cut, and so on. Okay? We're always going to have an offset between these two lines. So these are the examples we're going to have. You can see that the reading of the points of the x and the y direction are going to be a different way. Now that's what I'm going to do if I'm going to do the positive y, and if I'm going to go down, it's going to be negative y values in the incremental. If I'm going to move to the right, the x value will be positive. To the left is going to be negative. This will be useful depending on the diagram you are going to have. Usually they give you a diagram like this one and give you some dimensions on it. If they give you the points, you are going to have a circle, and this circle reference to the 0, 0 point, then you can do it. If they give you the dimension between the points, then you have to use the point-to-point in incremental values. You don't have to worry about the distance between these 2 points is given in the x and y direction. Just use the G91 and neatly divide according to these values. No need to calculate what will be these data to come to the 0, 0 point. Okay, now we explained these steps, and I think that this example became more clear for you. At the beginning, it was something circular thing you found in Egypt. You couldn't write anything, read anything, but now it's more clear. G05, M03, go to this point, which is going to be the starting point. The starting point is usually offset for the datum point by the value of the radius of the cutting tool and the minus direction of the x and minus direction of the y. So if I get to take it to minus 5 is at 30, that means my cutting tool will be below the datum point by the radius direction negative, the radius direction negative y, and the z is going to be at the top. At this position, just the circumference of my cutting tool will be in contact with the profile I would like to have. Okay, not the center, it's just the outer circumference of my cutting tool. You can use these steps to rewrite down your program for the example number 2 in the paper. So once again, we said that the pink one is going to be the tool pathing, and the pink is tool pathing, and the black is going to be the cutting path. Now in this example, we have almost all the things we are going to apply. Cutting in clockwise direction, cutting in counterclockwise direction, and straight line, and drilling. Okay, that's an example of the machining on the table CNC machine. The tool compensation is very important, which is the tool length compensation, the radius compensation, where we are going to have the offset. You have to do this one manually if you are going to do the program assistant writing or the manual writing. If you are going to use the cutting tool, you only have to define what will be the diameter of the cutting tool, and the calculation will be automatically by the software itself. You don't need to do the countering or the tool path, you have to the machine will do it. The cycle statement, then we'll have some examples. Okay, so actually this will be the three major phases of the program. This is a sample program. We have the percentage, which is the program start flag, the 2-point and followed by a number, which is going to be the 4-digit program number. Why do we need the 4-digit program number?
So that if you want to disable that there.
Exactly. So this one will be defined to the machine. Usually in the flexible or programmable manufacturing, you don't have to do the use the same machine to do the same program time after time. So it can change the program automatically. For example, each 3 hours you have to change your product in the flexible manufacturing. So you put all the jobs in the machine, and the machine is going to call it automatically on time. So this is a reference code for the user and for the machine to use the program. For example, in this laser cutter, on the screen there, when we are going to finish the work, send it to there, it's going to call it job number 1, job number 2, job number 3. So you can change the job number, run it, and it's going to do a different cut. So you can do multiple cuts on the same word part at the same time. Then number 5 is going to be G90 and G20. G90, that's where I'm going to use the absolute dimensioning. G20 is setting the machine units to inches. G20 inches, G21 is millimeters. If you're using the machine in average states, definitely it's all going to be set to G20 value by default. Yeah.
20 is millimeter.
21 is millimeter, G20 is inches. So if you are going to have, for example, engineering drawing, and you would like to make it, you got in American drawings, all the units are in millimeter and inches. No need to make change for the units. Just use it directly as in inches, but change the program to G20 instead of G21. Then we go to the next line, M06, that means stop the spindle. T number 3, use tool number 3. How we can do that? If we are going to use a current milling machine, the one with the disc, which contains minimum 6 cutting tools, that means we are going to stop the spindle, turn it to the next tool. This will be tool number 3. You have tool number on the turn by 1, 2, 3, 4, 5, 6, and that's how defined to the machine. The line number 3, M03, we start the spindle. S is 1,250 and 1,250 RPM. And then we're going to go with directly to the point where x1 and y1. That means y is equal x equal 1 inch, y is equal to 1 inch. The height is going to be 0.1 inches. The height, this solid cut, because we didn't change the GOO value. Then I'm going to do the drilling, G01 to the Z minus 0.125 beneath the surface with a feeder of 5 inches per minute. The line after is going to be go to the x equal to 3, y is equal to 2, and f is going to be 10 inches per minute. This cut will be linear interpolation without changing the GO value from GO1 to any value. So it's going to be just linear interpolation. Then G00 to Z equals to 1. Go to the position where x is equal to 0, y is equal to 0. M05, which is 10 of the spindle, and M30 is going to be end of the program. Now we can find the difference. I'm going to show you a table how these things are going to be done. So writing the program is something like writing a letter. We're going to have the first phase, which is the system setup. In the letter you have introduction. Then phase number 2 is going to be the material removal, which is going to be the actual work, which is the content of your letter. Then you finish it with the conclusion, which is the system shutdown. You've done all these things. Okay, now shut down the work, and I would like to take my sample. So these are the three major phases in any CNC program. Sometimes we are going to have subroutines, which is going to be within the phase number 2. Okay, so we said that this one is start program flag, the number of the identification number. These are the only two commands that don't start with data. We said that the encode, given the identifying number of the each block information, and it's generally good practice to increment each block number by 5 or 10 to allow additional block to be inserted within. We have the R and B codes. The R code in the old days was in the radius. And now when it's going to be followed by the, started with GO2 or GO3, the machine will read it as a radius. So you have to be careful at this point. Okay, the P code is used to specify the dual time associated with the G04 value, which is the hold of the dual for a certain time. These are the most common G and M codes. They're different from one country to another, but these are the most common ones. Among all these lists, well, actually I can give you a list which can go further than this one, but the one we are going to use are the G00, G01, G02, and G03. Then we go to the G21, if I would like to have the metric units. We can go to full circle, no need to do that. G90, G91, and for the M, the M00, which is the program stop, M01 optional program stop, we don't need that at this stage. We have the M03 spindle to be turned clockwise. The M04 spindle to be turned counterclockwise. Spindle stop M05. Tool change M06. Okay, cool on, cool off, and the clamps on, if I get to have automatically clamped on the machine. And the program to stop, process to start is going to be entered. So we talked about the exit value, IJK code. I'm going to pass this one because we explain what does that mean. Now the most important thing is the program in 360-degree arc. For the INJ, you give the center point and you ask the cutting tool to go to a certain point and cut in the arc. You have to set it's going to be G02 or G03. For the R code, the main problem we have is that the maximum arc cutting is going to do 359 degrees. They couldn't make it to cut 360 degrees. Now what will be the solution in this case? How you can overcome this problem? Yeah, just do it 2 arcs, each one is 180. Okay. And we're going to explain that in the example beyond. Okay, so I'm going to do that. Now for the example number 1, we have a part which contains 5 holes, and we need to cut the profile to remove 1 millimeter from the outside. We did the rough cutting, and we'd like to do the finishing by removing 1 millimeter from the sides. What will be the first thing I have to do to write down a G and M code? I have to analyze the job. Everything I will do will be at the beginning to set the datum point. Consider the machine you are going to use. Determine the program 0 point. Find out how many steps you should have, and find out what the kinds of the tool you are going to use, and begin the program. In such a program, if I'm going to use one spindle with one cutting tool on the machine, I should choose that my cutting tool diameter is going to be the same diameter of these holes, because this will reduce the time of the change of the tool if you have to do it manually. The same cutting tool is going to do the drilling and do the profiling. Now, what is the problem with this shape? Analyze it and tell me your suggestions. Just take a look at the shape. What do we need to do this work? Now, how you are going to fix a part on the milling machine. You have to hold it, right? Otherwise, you clamp it. Now, if I'm going to clamp this part, I will be able to drill it. Will I be able to do the profiling if I'm going to have the clamps holding the part? So I have to find a solution for that. This part is having a hole. The one you have in the assignment, the second one, doesn't have holes. We only need to do the profiling. So no device and nor the clamp will be able to be used. In this one, we are going to clamp it or using the device, do the drilling first. We are going to have a rectangular shape, which is the original stop, with holes. Exactly. We take off the clamps and use bolts and nuts. You have the slots on the table of the milling machine. We are going to fix the work part, do the profiling. That's easy job. Now what about the shape you have in your assignment? How you are going to do the profiling for the work part without using any clamp or vise? No, the second one. This one you can use the vise directly.
Directly was.
Yeah. But the other one needs to have a profiling.
Do we clamp at the home position?
You need to do the cut there as well.
Do we have access to really strong magnets?
You can. Well, actually, the problem with the magnet is that
The height of the function?
no, the height. Actually, the problem is that you have interference between the cutting tool, which is metal, and the magnet field.
Maybe you clamp one side?
You did that. Well, you did the manufacturing with me, right? In the lab. Yeah. So I told you about this technology. We can use the vacuum suction, hold it from the bottom, then you can do the profiling. Good? Now, that's for the example. You have to write down this one because in the analysis, we're going to say, okay, we are going to use 10 millimeter diameter slope cutter in this example because the diameter of your hole is going to be 10 millimeters. So the same cutting tool will do the drilling and the profiling. The speed of the feed and the feed rate is going to be, the RPM value and the feed rate is going to be suitable to the material they are going to cut, the cutting tool material. If I'm going to have the high speed steel cutting tool, I have to go to a lower value. If I'm going to cut plastic or wood, I can increase this value. If I'm going to use the carbide insert, I can increase the value of the RPM, so the feed rate value is going to be increased more. So that's what you have to be in certain limits. In this sheet, we said for the example number 1, the feed rate is going to be 600 meters per minute. It's millimeter. Sorry, that's something 600 millimeter per minute for the feed rate. So it's going to be in this example. Now for the clamping, we are going to use a packing material of a certain thickness to allow a proper clamping of the machining properly. So the packing material in the bottom, for example, is going to be the black one. We are going to save the table of the milling machine from damage when you do the drilling. Because these holes are going to be through hole. We said we have through hole, which is going to be the other side. So the cutting on the other side is going to be on the packing material, not the table of the milling machine. Okay, then we are going to remove the clamps, use the T-nuts and bolts to clamp the machine table. And then we're going to set the program 0, of course. Roughing is going to be the roughing of the machining left 1 millimeter above the final dimensions, and we have to remove this one by doing the finishing profiling. So the orange one is my original stock material, and I'm going to have the holes we drilled, and I'm going to sketch the path of the tool going to follow to have the final black path of the cutting. For the points you are going to have for the drilling, you can do point-to-point traveling. Because the traveling between one point to another is not going to do any work. Just take it from one position to another. Then you have to do the drawing and go up and do the other point traveling. So you can use either the increment or you can use the absolute dimension. The final path direction, cutting path we are going to have is the tool path we are going to have is the blue one. So from there you can set the data. So what will be the first position I have to take the cutting tool to be in contact with the datum point? My diameter is 10 millimeters, for example. We mentioned that before.
Of 5 millimeter.
By 5 millimeter in the x direction and the y direction. So it's going to be in the negative direction of the x, negative direction of the y by minus 5, minus 5. This will be my first point I'm going to start with. Then all my points are going to be calculated with relative to the 0, 0 points. I have to define it either clockwise or clockwise cutting or counterclockwise cutting. We can have two programs for the same cutting. Now, for the cutting we are going to have here, my cutting is going to be counterclockwise. For this radius, I'm going to have clockwise. Now you can see that the radius we are going to have here is offsetted more than the radius I'm going to have. But this one is going to be less than the radius I'm going to have. So you have to care about this point. We are going to do internal cutting for the radius. That means your tool path radius is going to be less than the cutted radius. You are going to do it offsetted, and you are going to have more. This one is less, this one is more. If this radius is 15, my cutting tool is 10 millimeter, so that means this radius is going to be 10. This one is 15, 10 millimeter diameter for the cutting tool. This radius will be 20. So you have to remember about these points. You lost aspect. No, that's aspect.
Like, can you explain it, the lambda cut for 20 become from...
Yeah, if you go it from outside, you are going to have tool path radius more than the cutted part. So you have to add the offset. If you do it from inside, your cutting tool path is going to be less radius than the cutted part, so you have to subtract the offset. Now in this case, we are going to have an arc as well. But the arc doesn't have to be 90 degrees. It's only going to go, for example, 45 degree or whatever degree I can have here, and this will be done by calculation. So the first step, if you would like to do the programming by hand, is to sketch the shape you are going to have.